So in this video I want to go kind of leftover things about the arrays, a few things that I didn't mention or maybe kind of forgot or didn't really know about. So first of all, what I want to do is how can we write inside values of our vectors or any attribute. Let's say I want to only affect the y vector inside my p position attribute. And the way I want to do is actually write all of these values inside array, and then from array actually modify the array. Let's say I want to add 2 to all of these numbers, and then from the array I want to copy these back inside our p.y. So how can we only affect one vector in our attribute? So first of all, let's create the loop. So first of all, we went to our vector. That's going to be our position. And for that we went to our array. But since our array is going to hold only the one value, so we don't want a vector array. What we want to do is just a float array. So float all position. Remember the brackets for the arrays, and now let's create our loop. So so our counter is going to be e, y, then is smaller than, since we want to run our points, so we want to do our endpoints. How many points we have, and then we want to add for each loop +1 for our I. So what we're going to do inside here, first of all, we want to get in our vector position our values for the p. So let's write inside our position is equals, and we want to read the point attribute, so that's going to be point. So 0, we're going to p for our attribute that we want to get, and our counter is going to be y, so that's going to be the point number that we want to get, like that. And after that we want to append. So we want to append all of these. We want all of these positions append to our array. And now this is where we're gonna do something different. So we know that our position is a vector. So one way we can address, just like the most basic thing, we can actually address for the append function actually just a y value. So all we have to do is pause that y. Let's add 4 or maybe 2. I want to do 2, like that. One thing I forgot to do is actually initialize this y value, so we have no value for y now. So just int y equals 0, like that. So now here value, and now it can count. So let's print out. One thing you will do is actually want to print out outside this loop, because if you print outside, you can see that it's going to basically print out 8 times this printf value. Now I want to bring back all of these array values back inside our y position. So with that, you can use a setPoint attribute. Let's go to the help, and this is going to work a little bit differently. So geohandle 0, the name is going to p for the attribute, the point number. So I want to run it over every point. So add ptnum. Now the differential is the value that you want to copy in. So for that, we have to use the set function. So we can't really, this setPoint attribute, since we are referencing p, we can't really say, let's say I want to p.y going to be, and then just write inside our values. We can't, for the vectors, we can't specify the pocket of the vector with this, basically, because attribute is the p attribute, position attribute. We can't specify that any one part of it, so we have to write an entire vector inside it. And so it expects also vector as a value for us. So that's why we can use the set function. And set function is very useful. We're basically going to set this value, and all we have to do right inside here is a vector. And with set function we can actually use the p.y, x, or z values. So since you want to only add to the y value, all we have to do is specify at p.x because we do not want to change it, and it's already p.x value exists, is going to be the same value as it is. And so for the middle it, for the y, since we wrote our y values and modified them in an array, we want to reference this array. So for the array, all pos, and now what we have to do in a square brackets, actually we have to specify which pocket of the array we want to do. Remember that with square brackets we can specify which one of these we want to do. Which part of the array we want. So let's say 4, and let's just take a look at how it's going to. And for the z, you want to add p.z like that. You can see the couple of things happens. First of all, position 4. If you take a look at our vector, since vector starts from 0, let's start counting. So 0, 1, 2, 3, 4. So 2.5, and you can see our y is 5. So if you want to 1.5, so let's say you want to address the third value in our array, so that's going to be 1.5. So, but we of course want to dynamically change it, because since our vector is just the same p.y values, only added 2 of them. So what we can do is, instead of 3, we can address it as at ptnum. So for every one of these, you can see we can now written inside every value from our array inside our position. And since we are running it over the at ptnum, we can actually copy it and get it outside the loop, because we don't really need it inside it. So because we are using at ptnum, and loop is actually not necessary in this case. So in loop, all we are doing only gathering information our y position inside the array. So and once we're getting it, so we can easily do it outside the loop. So that's a quick demonstration how can we get our vector values inside the array and then modify them whatever we want, and then copy them back inside y value without affecting x or z. Now let's go take a look at something else. Another thing in this video I want to talk a little bit about working with groups inside VEX. So we can reference groups just like entire geometry. We can actually reference only the part of the group when we create them. So what I'm going to do is actually create a tube. Let's make it, let's not no end caps, something like this. And let's put in Wrangle. And there are very many cool, there's basically they are basically the equivalents of the point and endpoints amounts only for the groups. So if you go to the help and write inside groups in VEX, you will find that there's basically the same basic functions with for the getting the number of elements inside the group, just like with endprim. Only thing that's different is basically endpoints group. So we are not referencing entire geometry, only the group, and we have to specify the group. Then there's how many elements. Then we can modify them, add to the groups and all of that. And let's just go through it and take a look at it. So first of all, let's create actual group. So put down a group node. Let's call it test. And let's select the points. So for the point, all I want to do is just one of these lines like that. So this is our group. And now you can see it's very easy. Endpoint group. And all you have to do is 0 and group name. So basically that's a test and that's it. Let's print it out. Actually not, let's put it inside the, so let's take a look at it. So you can see we have now 15 points inside our group. Another one is test if a given element number is in the group, so that's not too interesting, but this expand point group and prim group is actually very interesting. Let's copy it and let's paste it and just let's remove it and change it to expand from endpoint group to expand, because the syntax is actually the same. So let's take a look at what we have printed out. You can see it's basically gonna give us the array of the group, numbers of the group. You can see we are now array of all the values inside our group, so that's super useful. And they can also modify the contents of the name group. So you can see that we can actually add the values to the group or delete them with 1 or 0. So basically we're gonna give the primitive number to add or remove, and then the value 1 or 0 whether you want to what those values add or remove. For demonstration, what I want to do is actually, let's say we have this group that we created. Let's say I want to move this line to the next one and delete the rest of them. So maybe this is this like an UV seam and I want them not to be seen, so I want to move them on the other side. So since I like to make things complicated, let's do it in Wrangle. So first of all, we want to get the array that we can reference of all our values. So we know that this expand group did that, but instead of printing out, let's create an array that's going to store it. So let's delete all the prints and let's make an array. So since it's just a point of values, so that's going to be a float array, all pods, like that. Now let's like that. So now we have array that stores all of our point values inside here. And now what to do is just create a simple for loop. For, remember, int y equals 0. And so what we want to do, how many times I want to run this loop is how many points we have in this group. So we're gonna use this endpoints group. So what you can do is actually just copy this one. Let's just copy. And so the y is smaller than endpoint group, and then y plus plus. So we have to add one for every loop. And for our loop, what we want to write inside is actually modify the contents of name group. So that's going to use set point group. So just like we watched it, let's start writing it. So set point group. So first of all, we have to 0 for the geo handle. After that, the group name. So that's a test. After that, we have to give the, so let's take a point number. The point number that we want to run it over. So what we want to run it over is these groups. So we have to use our array. So all posts. And so in the square brackets, what we want to do is actually reference the y counter like that. And for now, let's leave it at that because we're still gonna have to modify it. And then the value that we want to write inside it. So basically 1 is to put point in a group or 0 to remove it. So we are referencing these points, which is basically the same group that we already have. And let's say you want to add, so that's 1. So you can see nothing is going to change right now. But if you want to add the next points, what we can do is actually to every one of these position values. So let's say in our loop we are taking the 231 point. So what you can do for every loop, we actually can add 1 to it. So since it's a tube, you can see that all the points are going in order. So if we add to the 231 1, it's basically going to flip to the 232. And every one of these is going to basically add 1. It's basically going to loop is going to move to the next selection. So what I'm going to do is actually create a channel. So post all of the loop and plus ch y. Let's create a counter. Let's press on this one. You can see now we have our counter channel. As you can see, we are doing basically adding 1 or the value of the channel to the next one, like that. One thing to note that once we are reaching, let's say we change these values, once you reach the 0, so let's see, we have 0 here, you can see it's basically going to break this edge loop, point loop, because 0 is 15, it's going to wants to add to the 1, but 16 is actually in here, so it's going to break our selection. So one way to make sure you have a full selection is actually be the group, actually select the group that already has a 0 in it. So now if you take a look and change it, we are getting a full edge selection. So any one of these edges now can be selected like that. So another thing I wanted to add is how can we get rid of these. So let's say I want to just move this edge selection, but let's say I want to delete the original one. So all you have to do is just copy this for each loop, and remember that we added this channel, so let's delete this channel reference. And since one is add, all we have to do is put 0 at the end of it. Now we are removing our original group, and our new group is just our first loop selection. One last thing I want to talk about is the getting max and min values from the vector whatever values we have in our attributes. So first of all, there is a max, min, average node, which is basically going to create a detail attribute with the max, min values from any attribute that we want to give. So let's say we want p.z, the max value 1.1, is going to write inside the detail. But what I want to do is actually, so this is very easy way to do it, but what I want to do is actually do it in the vertex or the practicing way for the practice. So we'll put down a wrangle node. So first of all, I want to, just for the change, let's do it with the vertex attribute. So just put inside UV unwrap, so that's going to give us a vertex attribute UV. You see that UV is actually populated only in two ways, so two pocket, because it's a two-dimensional image of the UV. So remember that, and the third one isn't really used because it's 0. So for the actual code, let's create first of all, let's create vector. Let's create vector position. After that, let's create a float. So this is going to be our array that's going to hold our information from our UV attribute. So now let's create our loop. Let's for. So let's our counter it y equals 0. After that, we want to run it as long as we have how many vertices we have. So that's going to be n vertices. So y is smaller than n vertices. That's going to be 0. After that, y plus plus. So now let's write inside it. Let's write also in our position vector our values of UV. So it's going to be vertex function now. 0 UV, and that's going to be y as our counter, like that. For our append function, what we're going to do is append only the y value of our position vector. So now that we have got our in every loop that it does in our position, we have the vertex value as a vector. Since our array is a float, we can't really store the vector value in our array. So what we have to do is just specify the y values of our UV attribute. So post.y like that, and that's it. Now we have appended to our array only the y values of our attribute. And with that we can also print out. I just wrote it down. So if you print it out, you can see, like that, you can see we have printed out all of the y values of our UV attribute. And to store our values in our detail attribute, all you have to do is use a set detail attribute function. So for that, all you have to do is 0 as a geo handle, and then the attribute name. So if it doesn't exist, it's going to create it. So let's call it my max, and then all we have to do is use the min. For now, it's max function. So for max, all we have to do is reference our array, all post, like that, and that's it. If you take a look at our detail, you can see we are now referencing 0.63, and you take a look at our vertex, and you can see it's 244. It's 244. So that's our biggest value of our y pocket of a vector for our UV attribute. And do the same thing with the my min. Instead of max, it's a min function, like that. Now we have 0 and 0.63 as max, and that should be about right, like that. So you have basically done the same thing as with the dmax. What is it called? Dmax mean something like this node, which is obviously a lot more convenient than writing this code if you want to do this simple task. But it's good to know how to do things and how we can get, extract, and write values inside attributes. I hope you learned something from this video, and see you next time, and take care.